Okay, welcome to lesson 5.6 on percent, ratio, and rates. And in this lesson, we're now going to talk about equivalent ratios. And the objective is the students will understand that equivalent ratios means that they're equal. They will write equivalent ratios by using both multiplication and division. So we're going to do some exchanging or some converting. And you're going to learn to simplify a ratio to its lowest form in order to use them for comparisons. So let's start with something simple. Even though the lesson is long, it's a lot of pictures, so it should go fairly quickly. So what is the following? Consider the following sets of pictures. What is the ratio of elephants to seals? Well, you should be able to look at this and very quickly see, well, there's basically one elephant. So 2 seals. All right. Now, what if I double that? Take the same pictures, I just doubled the pictures. So now I have elephants to seals. Now I've got 2 to 4. But you should have realized that when you take a look at elephants to seals, the ratio of elephants to seals of 1 to 2, this is a 1 to 2, and this is also a 1 to 2. So even though I've doubled it, the ratio of elephants to seals, there's 1 elephant for every 2 seals. Let's go one step further. Let's triple it. Now I've got 3 elephants for every 6 seals, but this is a 1 elephant for every 2 seals. This is 1 elephant for every 2 seals. This is 1 elephant for every 2 seals. When we did the doubling, we found that they were both 1 elephant for every 2 seals also. Right? So you're starting to see something forming here. Let's take the last set. Now I'm going to quadruple it, multiplied by 4. All right. What's the ratio of elephants to seals? Well, I've got 4 elephants, and I've got seals. I got 2, 4, 6, 8 seals. But you'll notice I'm still 1 to 2 for every set, aren't I? Doesn't matter how I mix this up. There's always 1 elephant for every 2 seals. So what do you notice about the sets? The ratio of elephants to seals remains the same. Even though the numbers have actually changed, the relationship between the numbers of elephants and the numbers of seals hasn't changed at all. We call these equivalent ratios. Now when I write them as a fraction, you may see there's our first one, 1 elephant for every 2 seals, 2 elephants for every 4 seals, 3 elephants for every 6 seals, and 4 elephants for every 8 seals. You should have noticed these are equivalent fractions. Multiply the first fraction, 1 over 2, top and bottom both multiplied by 2 gives us 2 over 4. So that means that they're equal. 1 times 3 is 3, and 2 times 3 is 6. That means that's equal. 1 times 4 is 4, and 2 times 4 is 8. So these are all equivalent fractions. Now, if they're equivalent fractions, that means that they have to also be equivalent decimals. So if you take and divide 1 divided by 2, that's 0.5. 2 divided by 4 is 0.5. 3 divided by 6 is 0.5. And of course, 4 divided by 8 is 0.5. So not only are the ratios the same, the fractions are the same, and the decimals are the same. So you have to be able to create and recognize equivalent ratios. So let's start by creating equivalent ones. I want you to create a ratio of x's to o's, which is 3 to 2. All right, so my x's to o's. 1, 2, 3 x's, 1, 2 o's. 3 to 2. Now I want you to create another ratio of x's to o's, which is equivalent to this one. So do the same thing I did with the elephants and the seals. Well, my first one was 3 x's to 2 o's. If I just double everything, I still have 3 to 2 in both places. So even though it is 6 to 4, when you reduce 6 to 4, you end up getting 3 to 2. So these are both equivalent. This one here and this one here are equivalent. And remember, equivalent means equal. So how do you come up with the numbers of x's and o's to include in your second drawing? Well, what we did is we took our first drawing, and you have to put a multiplier in here. I used multiplying by 2. Somebody else might have multiplied by 3, in which case theirs would look like this. There's multiplying by 3. All right. So you multiply both terms of your ratio by the same number. Doesn't that sound familiar? Multiply both terms of the ratio by the same number. Now, you probably remember this is how you create equivalent fractions, by the same number. Okay? So, think about it. If you had 3 to 2, and you wanted to create an equivalent fraction, multiply everything by 2, that gives you 6 to 4. That's equivalent. If you had 3 to 2 as a fraction, you multiply both of them by 2, that gives you 6 over 4. Right? So both of these give you the same, I won't say the same thing, but you treat the process the same way. You can create equivalent fractions by multiplying the first and second terms, or the first, second, and third terms by the same number. Is there another ratio that is actually equal to the ones that we created up here? Well, if you multiply by 2, you get 2 of them. You multiply by 3, there are an infinite number that you can use. Okay? So there is, or R, is an infinite amount of equivalent ratios, just like there's an infinite amount of equivalent fractions. I never know how to spell equivalent. Wish this board had a spell check. All right, moving on. All right, here we go. I want you to create a drawing of objects to match the ratio of 1 to 3, and then I want you to draw another drawing with the same equivalent ratio. And you can use whatever you wish for your ratios. So go ahead. There we go. You should be done by now. So I have to create 1 to 3. Well, I like X's and O's, so here's my first one, X, 1X, 2, 3 O's. Now, there's the first drawing. Now I want to create another drawing with an equivalent ratio. I'm going to use a multiplying factor of 4 this time. So I've got 1, 2, 3, 4 X's. But then I have to have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4 sets of O's. Now if you take a look at it, this is 1 to 3. This is 4 to 12. If I want to get from here to here, all I got to do is multiply by 4. Now what if you had 4 to 12 given to you? If you wanted to get this, draw another one equivalent to 4 to 12, you could draw one which is 1 to 3. That's just dividing both by 3, by 4, and that gives you an equivalent ratio also. So what is an equivalent ratio for 12 to 36 that's not found by multiplying? So I want you to try this one. This is just like reducing a fraction. Okay? Pretend the fraction is laying on its side. So 12 to 36, I'm going to divide it by 2. So one equivalent ratio is 6 to 18. Half of 12, half of 36. I could also divide by, this is divided by 2, I could also divide by 3. 12 divided by 3 is 4. 36 divided by 3 is 9. So are there others? Well, we start listing them all. We've got 12 to 36. We divide by 2, that is 6 to 18. You divide by 3, that's 4 to 9. You divide by 4, that's 3. Nope, can't divide by 4. Sorry. Yeah, we can. I got something wrong here. Oh, what did I do now? There we go. All right, let's, half of 36 is 18. All right, so divide by 3. Oh, there we go. This becomes 4 to 12. Divide by 4, you get 3 to 9. There we go. And if you divide by 12, you get 1 to 3. So those are all the ones that are possible. Okay. Now, how did I simplify these ratios? Well, if this was my original one. Here I divided by 2. Here I divided by 3. Here I divided by 4. And here I divided by 12. All right. And I also could have done 6, I guess. Divide by 6. That is 2 to 6. Now, you probably noticed something here. These numbers here are the factors, and these ones here are the factors. So they're Very similar, aren't they? Let's take a look. Simplifying a ratio. Simplifying a ratio is similar to simplifying a fraction, however the steps are in a single line. So for example, what is the simplified form of 2 to 6? Find a number that divides into both 2 and 6 and reduce it like a fraction. One way looks like this. Now I'm assuming this is a part to whole, all right, because I'm able to write it as a fraction. If it was a part to part, I couldn't do that. Now the other way looks like this. That gives you 1 to 3. Both ways look like, or both are acceptable. The other way I already did in the previous form, okay? So if you work in fraction form, make sure you place the ratio back into its ratio form when you're done. So let's have you try this one here. Reduce 4 to 24, please. All right, you should have paused and back by now. 4 to 24, we have two options here. I can treat it like a fraction and divide it into each one. I notice a 4 goes into both of them. 4 divided by 4 is 1. 24 divided by 4 is 6. So there is one way. Now putting it back like that, put it back into its ratio form. The other option is to treat it like ratio and just keep it in ratio form, but just do your dividing here. Okay, and then that becomes 1 to 6. All right. Some people like to do this. Just sort of do dividing that way. I still get 6. So the ratio form is 1 to 6 when it's reduced. Sometimes the ratios are more than 2 terms. Now this is like finding the common factor of 3 numbers. All right? So I'd like you to try to reduce this all the way. Now remember, you cannot have a decimal. I'll pause the recording and see how you do. Okay, so here we go. What goes into 4, 12, and 18? Well, I happen to know that 2 does because they're all even numbers. So I can divide every one of these by 2. 4 divided by 2 is 2. 12 divided by 2 is 6. And 18 divided by 2 is 9. Now don't fall into the trap of trying to reduce these two or these two. They have to all be reduced together. So even though 2 goes into both 2 and 6, it doesn't go into 9, so that means you can't use it. So this here is your final form. You cannot reduce it any further. Let's go to the next page. Here's another one for you to do. 24 to 6 to 72. Pause the recording and do that one. All right. What goes into all of these? Well, if you know your multiplication tables very well, you'll notice that 24 is divisible by 6, 6 is divisible by 6, and 72 is also divisible by 6. So 24 over 6 is 4, 6 divided by 6 is 1, and 72 divided by 6 is 12. Now, if you couldn't figure out it was a 6, you could have started it with a 2. That would have given you the following. We have 24 to 6 to 72. You can divide by 2. That gives you 12 to 3 to 36. And then you can divide everything by 3. And that will give you 4 to 1 to 12. So both ways work. Find the missing number in a ratio. So now what happens if you're given a ratio of something and one of the numbers is missing? So Brett spilled coffee on his textbook while working at his desk. The ratio showed the following, 3 to 8 and blank to 24, where the coffee was spilled over this number, so he didn't know what it was. How can he find the missing term? Well, if you treat this like 2 equivalent fractions, it becomes very simple. We've done this before. 3 over 8, the first one over the second, is equal to x over 24. Now you remember a long time ago, a couple lessons ago, I told you about using the proportional method to solve problems. Here's where it comes in to be very, very handy. Okay, so how do I get the x by itself? You take the 3 over 8, you multiply it by 24, x over 24 multiplied by 24, these cancel, and 3 over 8 divided by, 3 divided by 8 multiplied by 24 gives you an 8. All right, now that's one way of doing it. Another way would be to take and figure, how did you get from 8 to 24? You multiplied by 3. How did you get from a 3 to a 24? You multiplied by 8. Sorry, by, well, I guess you can't do it that way. Let's back up here. I think I made a mistake in my math here somewhere. 72. This is supposed to be 9. That's better. Just looking at my math going, wait a minute, the process I just used should have worked. Yeah. So for 8 to 24, you multiply by 3. So you multiply this by 3, you get 9 to 24. So it works just fine. Okay. Now this is the method that we used in grade, I can't remember what grade we did that in. All right. But we were using equivalent fractions, and we gave you an unknown box with 24, and you had to figure out how'd you get from here. All right. And whatever you did there, you had to do the same up here. It's the same thing. However, this method works really well when you can figure out how to get from 8 to 24. But what happens when that's a 23? All of a sudden, this method falls apart and is no longer usable. And then you have to step up and use this method anyway. So my advice is, don't shortcut and try the other way. Use the way that we're doing it now. It'll be easier. Okay, now, 2 to blank and 3 to 7. So, first one over our unknown, I'll call it the x. First one over 7. We have just hit a flip question. So here we go. Flip both sides. Multiply both sides by the number under the variable, which is the 2. These cancel, leaving you with x. And 7 divided by 3 times 2 gives us 4.6666 repeating. So our answer is actually 4. It says round to the nearest hundredth, 4.67, because there's your cutoff. So this is where your proportional method comes in handy. If you memorized how to do it, it goes easier. Now let's take a look at a triple one. Rhett is cooking at home. He found a recipe on the internet that sounded different. The recipe calls for a ratio of 2 cups of sliced pineapple to sliced oranges to sliced turnip of, so I said 2, a ratio of cups of sliced pineapple to oranges to turnip of 4 to 6 to 5. Unfortunately, he only has 2 cups of sliced turnip. So how many cups of pineapple and oranges does he need? Well, what we do is you take a look at the 2 numbers that match up. The 5 and the 2 are both turnips. All right? So what we need to do is make a fraction out of those. So I'm going to take a look here. I'm going to take the 5 over 2, and I'm going to start with the first one, which is pineapple, which is 4 over 6. So you take your 4 over 6, and you make it equal to your 5 over 2. It's 4 over 6, sorry. I screwed that up. 4 over box. Okay? You take a ratio, it'll be 4 over box right here, and you make it equal to 5 over 2. So now this here is your x. So now how do you solve it? You flip it. X over 4 is equal to 2 over 5. Do the same thing to both. I'm going to move over here because I ran out of energy, out of room. So that becomes x over 4. You multiply by the number under the variable. And 2 over 5 times 4. These cancel, leaving you with x, or your box. And 2 divided by 5, multiply that by, I guess that's a 4 there, gives you an answer of 1.6. So he needs 1.6 or 1 6/10 cups of pineapple. Okay, and I think I just messed up here. I think I have all of this in this page when I'm supposed to put it on the next page. Yep. So here's what I should have done over here. All right, so just take the previous page. This stuff right here, what is the relationship between the 2 known quantities? The relationship between the 2 known quantities is the 5 to 2, or 5 over 2. All right, this part down below here, I'm just going to take that, and you don't have to worry about changing your notes. You can just take and just work from page to page, but I'm going to grab them anyway and just copy this and put it on, I'll just cut it and put it on the next page. So there's the answer to that one. Okay, so he needs 1.6 cups of pineapple. So now the next thing to do is to do the same process for oranges. Now do not use the 1.6 pineapple here. The reason for that is if you start to get in that habit, one of these times you're going to get a rounded number that you would have to round here. And when you put a rounded number into the relationship that you're trying to form with the other ratios, what's going to happen is you've actually put in a number which is an approximation and not an exact. We have an exact ratio of 5 to 2 here. So I'm going to go back here. Our ratio was, where are we at here? 4 to 6 to 5. All right, and it was equal to box to box to 2. All right, so this is what we were working with earlier. All right, now we solved the 5 to 2 ratio. So we used the 5 to 2 ratio to solve the 4 to box ratio. So now what we're going to do is we're going to do the exact same thing. I'm going to use the 5 to 2 ratio to solve the 6 to box ratio. It's the same thing. First one over second one. That's your x right there. And first one over second one. Put them equal, becomes a flip question. So x over 6, flip that one. 2 over 5, flip that one. X over 6 times 6 is equal to 2 over 5 times 6. And that means that this cancels. So x is going to be equal to 2 over 5 times 6, which is 2.4, I believe, isn't it? Lost my numbers here. My notes say, fix this, it's wrong. So let's take a look at this. I've got 2 over 5 times 6. So 2 times 6 is 12 over 5. So x is going to be equal to 2.4. There we go. So Brett will need 2.4 cups of sliced oranges. And that hopefully will work. Let's take a look at the next example on the next page. Find an equivalent ratio for 5 to 4. So I want you to try that one, please. Pause the recording and go at it. All right, so again, take your 5 to 4. If you want to make an equivalent ratio, choose a number to multiply by. I'm going to choose a 6. All right, now 5 times 6 is 30. 6 times 4 is 24. There I go, I'm done. So to create an equivalent ratio, you can multiply by any amount. Now, what I mean by any amount is that you got to make sure you don't turn it into a decimal. Right? We don't do that at this stage. Okay, there are ratios with decimals later, but not right now. So you have to multiply by a whole number. That concludes 5.6. If you have any questions, go back and watch it again. If you still have questions, come in and see me. And we will see you in the next lesson.